We have studied about the Armstrong axioms, so I wanted to do some practice questions other than the ones I already discussed in the video because we will be needing this for normalization, however. So we'll do some practice questions. Okay. So the question will be the simple question. We have to find out the candidate keys. Okay. We have to find out the candidate keys. That will be the question. And we will look at some scenarios and we'll just find out the candidate keys. Yeah, fine. So there are some simple steps to follow to find out the candidate key. So first of all, we'll start with everything functionally determines everything. So we know the reflectivity rule, right? In reflectivity rule, if A is a subset of X, we can say X functionally determines A. Yeah. According to this, we also come up with X functionally determines X. Why? Because X is also a subset of X, so we can say X functionally determines X. So this is what we are going to start with. First of all, we have to start with that. Okay. So in this case, we have A, B, C. Yes. So we will take all the attributes. So this is the step one. Okay. This is the step one. So we have A, B, C. So we can say A, B, C functionally determines A, B, C. Okay. So by using this one, we can actually find out the candidate keys. So we have the step one. Now check for the functional dependencies. Okay. Here we have two functional dependencies. F functionally determines B and B functionally determines C. Yes, sorry, not F, A. Okay. So here we have A functionally determines B and B functionally determines C. So here we can also come up with, by using this, we can also come up with A functionally determines C according to the transitivity axiom. Transitivity axiom. So we have A functionally determines B, B functionally determines C, and A functionally determines C. Okay. By using the union rule, we can say A functionally determines BC. Okay. So we have come up with that. And since A functionally determines A according to the reflectivity rule, we can say A functionally determines ABC also. So this is the derivation process. Okay, derivation process. So now we know A functionally determines ABC. So we can say A functionally determines ABC. We can remove BC. Why? We can come up with this. That's what. So we have A functionally determines ABC. Now we have found out a super key. This is a super key. Why is it a super key? Well, it functionally determines all the other attributes, the sets of attributes in the relation. Okay, so we can say this is a super key. But the question is, we have to find out the candidate key. Okay, we have to find out the candidate key. To be a candidate key, okay, to be a candidate key, okay, to be a candidate key, super key should not have any subsets. Okay, super key should not have any subsets should not have any subsets should not have any subsets which are super keys themselves. Super keys themselves. That's it. Super key shouldn't have any subsets which are super keys themselves. But A is a single attribute set. So we can say A is a candidate key. A is a candidate key. So we have candidate key list. In candidate key list, we can have A. Okay. What about the prime key? Yeah. What about the prime keys? We'll also write that down. Yeah. Prime key attributes. So prime key attributes, we have A, comma. Do we have anything else? Well, A functionally determines ABC. That's the first step we have completed. And in the second step, we also checked for the step two is checking whether there are other super keys inside that specific value. For example, if we had like AB functionally determines ABC, we will have to break down this. Okay, we have to break down A and we have to break down B. And we have to check what A functionally determines and B functionally determines. Since we know A functionally determines ABC, we can say AB can be a superset. but AB is not a candidate key. Okay, sorry, it can be a super key, but it's not a candidate key. That's what the step 2 is. So we have completed step 2. Now we have to see whether A functionally dependent on any other attribute. Well, we can see that A is not functionally dependent on any other attribute. So according to step 3, we can say A is only dependent on A, is only dependent on A. Other than that, there is no other dependencies of A. So we can say A is the only candidate key and it is the only prime key attribute. If you want to check, you can check. We know C function determines nothing. Okay, C function determines only C. And B functionally determines C. So we can say it functionally determines BC. And we know A functionally determines ABC. So speaking of which, we know A functionally determines ABC. This is the only proper candidate key that we have. Now let's do this question. So we always start with the step 1. Step 1 being everything functionally determines everything. So A, B, C, D functionally determines A, B, C, D. Now let's check the functional dependencies. We have A functionally determines B and B functionally determines C. So we can say A functionally determines C according to the transitivity rule. Okay, from these two we can say A functionally determines C. A functionally determines C. Now we also have A functionally determines D. Okay, so we can say A functionally determines B, A functionally determines C, A functionally determines D. So by using the union transitivity axiom, we can say A functionally determines B, C, and D. But we know A functionally determines A. That is the reflexivity rule. So we can say A functionally determines A, B, C, D. By using this, we can replace everything with A functionally determines A, B, C, D. Now we have found out the super key. That's the first and foremost step. We have to find out the super key. Once we have found out the super key, we have to check for candidate key. Since A is an individual set, we can say step 2, A is a candidate key. A is a candidate key without any doubts. Okay, A is a candidate key. So we can update the set candidate key set. Candidate key will have A and the prime key set where we will have A. Now we have to check whether A is functionally dependent on anything. Well, that's the step 3. But fortunately, A is functionally dependent on only A because A is not on the right side of any of the functional dependencies that are given. So A function determines A is the only way. So A is not functionally dependent on anything else. So only candidate key is A and the only primary key is only prime key attribute is A. Keep that in mind. So this is how you have to do this question. Now let's try this question. In this question, we will start with the first one, first step, step 1. This will be A, B, C, D, E. Functionally determines A, B, C, D, E. Now we can actually follow this and find the answer. First of all, we'll check all the functional dependencies we have. A functionally determines B, A functionally determines C. So I can actually say A functionally determines B, C. That's not an issue. And then we have B functionally determines D. Okay, B functionally determines D. So I can say A functionally determines D. Why can I say that? Well, speaking of which, this is transitivity rule. So I can say A functionally determines B, C, D. Now we have AC functionally determines E. Okay, the thing is here we have AC functionally determines E. So we can't actually say A functionally determines E. Okay, we can't directly say that. Okay, because we have A and also C. Okay, so how can we deal with this? Well, let's check this and this. Okay, let's check this and this. Okay, here we are speaking about pseudo transitivity. Okay, we know according to pseudo transitivity, if X functionally determines Y and WY functionally determines Z, we can say WX functionally determines Z. This is the pseudo transitivity rule. Check here. A functionally determines C. AC functionally determines E. So we can say AA functionally determines E. AA is nothing but A. So A functionally determines E. We also have that. So we can say A functionally determines E also. So from this to by applying pseudo transitivity, we can say A functionally determines E, which means A functionally determines B, C, D, E. So we also can say since A functionally determines A, okay, that's an obvious axiom. So we can say A functionally determines A, B, C, D, E. So we can say A functionally determines A, B, C, D, E. So we have found out the super key. Very well. Now we have step 2. We have to find out whether that's the candidate key. Well, that is the candidate key. Why? It is an individual set of attributes. So we can say A is the candidate key. So I can update that candidate key A, find key attributes A. Step 3, I have to check if A is functionally dependent on any other given set of attributes. Well, we don't have A on the right side, so we can say A is a candidate key, is the only candidate key. A is the only candidate key. That's all. So this is how you have to do this question. Now let's do this question. In this question, we have 6 attributes and some of the functional dependencies. So first of all, we have to find out the super keys that are possible. So we'll start with A, B, C, D, E, F. Functionally determines A, B, C, D, E, F. Fine. So we have A, B functionally determines C, and A, B functionally A, C functionally determines D. We have C functionally determines C. So we can say AB functionally determines CD. And we know AB functionally determines AB. So we can say AB functionally determines ABCD. That's great. Now we have DE functionally determines F. Okay. DE functionally determines F. Well, that's great. Now they have given A functionally determines E. So we can actually say, okay, we can actually say since A function determines E, we can say dA functionally determines F. So which means AD functionally determines F. We can say that. Well, what else can we say from this? So that's good. So we have D here, A here. We have A here, B here. And since we know A functionally determines E, we can also say AB functionally determines A, B, C, D, E. Okay, we can say that. Why? Well, in this case, we have A functionally determines E. Okay, A functionally determines E, and we also have AB functionally determines. We can say AB functionally determines BE. How can I say that? Well, I'm just including, adding two new attribute sets to the functional dependency. This is the second axiom. It's called the, do we have as the second axiom? The augmentation axiom. Okay. According to the augmentation axiom, this is possible. And since we know AB functionally determines ABCD, we can say AB functionally determines ABCDE. That's what I came up with. Okay, fine. Now, since we know AD functionally determines F and AB functionally determines D, okay, we have AB functionally determines A, B, C, D, E, and we know AD functionally determines F, okay. So we can use that also to our, well, actually, like DE functionally determines F, okay. Here we can say AB functionally determines DE. By using what? The decomposition rule. Okay, we can say that. So we can say, and we also have DE functionally determines F. So we can say sorry, AB functionally determines, AB functionally determines which ones? A, B, C, D, E, and F. Okay, that's it. So we have AB functionally determines A, B, C, D, E, F. Okay, A, B, C, D. Fine. So in this case, we have come to a conclusion that AB is a super key. Now we have to check whether it's the candidate key. We have to check whether it's the candidate key. So let's break this. If you break A, B, you will get A and B. So what about A? What does A function determine? A function determines A. Obviously, we know that. And A function determines E. Okay, that's okay. But other than that, there is nothing else we can do. Okay, because here we need A, B together. Here C and D, nothing to do with that. Here we have D, E, and here we have F. But the thing is, A functionally determines E is fine. And we can replace E with A and we can get DA functionally determines F. No worries. But the thing is, we need A, B together, not only A. So that is also not going to make any changes in this one. And what about B? What does B function determine? B function determines only B. Why? There is no functional dependencies written based on B. So we can say AB is a candidate key. So you can write down BK equals AB, comma, and we can say primary key attributes are A, comma, B. Okay, that's it. Now we have to check, is there anything else? Is there any dependencies that affects A or B here? Okay, so let's check. Is A here in the right hand side? No, 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 and no. So AB is the only candidate key. AB is the only candidate key. Okay. Or you may think, well, since we have AB here, you started with AB. What about CD? Or how can we do with CD? Well, you can, if you have any doubts, you can check that too. Okay. You can check that too. If you have any doubts, you can check that too. Okay. Shall we check? Fine. So we have C functionally determines D. Okay. And we have DE functionally determines F. So we can say CD, sorry, CE functionally determines F. Okay, so we can say CE functionally determines, but we have D here. Already we can say C functionally determines C, so we can say C and we can add E and we can add F. Okay, C, D, E, F. But other than that, you don't have anything else. Other than that, you don't have anything else. Why is that? Because we don't have A or if you put AB here, you will have to add AB this side too. But we know ABCE functionally determines ABCDEF. But the thing is, here AB is a candidate key. So even though ABCE is a super key, AB is not sorry, ABCE is not a candidate key. Why? The proper subset AB is also a candidate key. So it can't be a candidate key. ABCE cannot be a candidate key. It can be a super key, but it's not a candidate key. And we know already if AB is a candidate key, okay, if you add C to it, this will also be a super key. If you add E to it, this will also be a super key because it's a superset. It's a superset of AB. So it doesn't matter. Okay. So this is how you have to do these questions. Okay. Now let's do this question. In this question, we have 7 set of attributes. So let's mark that first. Step 1, A, B, C, D, E, F, G. Functionally determines A, B, C, D, E, F. Okay. Now we know A functionally determines B. Okay, A functionally determines B. So I can actually remove B here from this. Okay, or you can do everything if you wanted. Okay, you can do one by one. So we have A functionally determines B, and here we have B functionally determines C. So we can say A functionally determines C. By using that, I can come up with A functionally determines A, B, C. So this BC is useless. Okay, this BC is useless. Fine. Now, what else do we have? Well, AC functionally determines B is there. AC functionally determines B is there. But we already know A functionally determines C. So we can say AA functionally determines D. So which means A functionally determines D. Now I can add A functionally determines A, B, C, D. Okay. So B, C, D is also useless in this case. Now we have E. Well, AC, this is also used. But the thing is, E functionally determines A. Here we have E functionally determines A and E functionally determines F. So I can say, since E functionally determines A, I can say E functionally determines A, B, C, D. And I can also add E. Why? E functionally determines E. And E here functionally determines F. I can say E functionally determines A, B, C, D, E, F. I have used that data also. Here D functionally determines G. If I break this by using decomposition, I can say E functionally determines D. And here I have D functionally determines G. So I can add this to, I can say E functionally determines G. So I can say E functionally determines A, B, C, D, E, F, G. Okay. So everything goes. So we have E functionally determines A, B, C, D, E, F. Okay. Fine. But what about A? Did we end with A? Let's check with A. Okay. E is fine. E is good. I'm not gonna lie. But let's try A. What else we can do with A? So A function determines A, B, C, D, that's fine. But other than that, A has nothing else to do. Well, A function determines D, so D function determines D, we can say A, B, C, D, G. That's not an issue. Okay, that's possible. But other than that, there is nothing else. Okay, to determine E and F, we have to add E and F. Okay, I mean, we have to add E. So A can be used to determine A, B, C, D, E, F, G. That's not an issue. But the thing is, E functionally determines A. So it's only E functionally determines AB. So however you will be coming up with this. Okay. So we know the super key and we know this is the candidate key. Why? It has no subset. So that's it. So that's all. That's the candidate key and that's the prime key. But what about others? Well, because since E functionally determines F, E can only functionally determine F, we can say that's the only way that can happen. Yeah, because E functionally determines F, and we have also found out E is the candidate key. So there cannot be other candidate keys. Okay, so keep that in mind. So the candidate key is only E, and the prime key attribute is also, there is nothing else. Okay, now let's check this question. So here we have four sets of attributes. So we have A, B, C, D functionally determines A, B, C, D. Okay, now let's start with AB. Okay, we know AB functionally determines C. Okay, and AB functionally determines C, and there is C functionally determines D. So we can say AB functionally determines D. And using union properties and reflexivity, we can say AB functionally determines A, B, C, D. So AB is a super key. Okay, AB functionally determines A, B, C, D, and AB is a super key. Okay, the super key. We have to check whether this is the candidate key. So we'll break this down. Okay, we are going to step 2. Let's break this down. So we have A and B. What about A? A function determines nothing. A function determines nothing. So A function determines A only. And B to alone, only function determines B. There is nothing else. So we can say AB is a candidate key. Why? There is no super key inside the subset of AB. So AB is a candidate key. So we can say candidate key list. We can update AB. Okay. And prime key attributes, we have A, comma B. Very well. Fine. So now step 3, we have to see if they are dependent on anything else. Okay. Here we have AB functionally determines A, B, C, D. But the thing is, here we have D functionally determines A. Okay. So we have pseudo transitivity here. D functionally determines A and AB functionally determines A, B, C, D. So we can say BD functionally determines ABCD. Can't we say that? Can't we say that? Why? Here we have AB and here A. So instead of A, I can replace with D. That's the pseudo transitivity. So I get ABCD. So I can say another one. Okay. It's, again, we are coming back to first step. So BD functionally determines ABCD. Now we have to check whether a set of BD is a proper subkey. Sorry, proper super key. So B, obviously it's not super key. Why? We already checked that. For D, we have D, and here we have A. Okay, here we have A. So that's not going to work. That's not going to work. So we can say BD is a candidate key too. So we have BD, which is a candidate key. And yeah, I can add that D to this list. Fine. Now we can't stop. Now also we can't stop. Why? BD functionally determines ABCD is there, no worries. But here we also have CD functionally determines C functionally determines D. So here also there is a pseudo transitivity. So I can say BC functionally determines ABCD. Okay, so this is also a super key. Now we are going back to again step one. We have to check whether it is a candidate key. Well, we can actually. So B, obviously it has only B, and C functionally determines what? C can functionally determines D, okay, and C functionally determines D, and D functionally determines A, so it can functionally determine A, and obviously C can functionally determine C. So well, we can say C is also not a super key. So we can say BC is a candidate key. We can say BC is a candidate key. So I can add C. So all are prime key attributes. Now, shall we stop? No, we can't stop. Why can't we stop? We have to check whether the subsets BC as any other are they functionally dependent on anything else? Well, BC, here we have C. Okay, C functionally dependent on AB. So I can replace that. So we get B, AB. Well, that is actually AB, and we know AB is already a candidate key. Why? We check that. So this will be a loop going around if you keep doing it again and again. So we can say BC is the final candidate key. So we have three candidate keys here and four prime key attributes. If I rewrite them, you will be able to understand that easily. AB, BC, and BD. And prime key attributes are A, B, C, D. That's it. This is how you have to approach this question.
Thank you for joining us in this hands-on session on Armstrong's axioms and candidate keys. If this video added value to your learning, give it a like and share it with your friends. Subscribe to the channel and hit the notification bell to stay updated with more videos in this series. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.